Challenge. Now, inshallah, the boring part is over. So let's begin. Now, the next thing that we're doing is what is known as the Hardy-Weinberg theorem. So there are two aspects to this thing. There is a mathematical derivation part. We don't need to go into that. Like as a concept, we need to understand. So I will quickly explain and then we will jump on to a past paper question for Hardy-Weinberg theory. ठीक है जी. Okay. Now, again, to set the context, you need to understand that I talked something about what was known as the allele frequency. ठीक है, allele frequency. और इसको थोड़ा सा natural selection के साथ we need to relate this with the natural selection. And we need to understand that when we are trying to understand that natural selection has happened. Now listen carefully, बच्चों, this is slightly important और थोड़ा सा समझने वाली बात है. Once you get this basic idea, inshallah, this should not be an issue. So, as I said, when we are considering that natural selection happens or has occurred, yeah, evolution has occurred, we actually mean all of that following के जो better alleles हैं, the ones that code for better phenotypes, they survive. I mean, the organisms, sorry, that have better phenotypes, they survive, they tend to reproduce more, and they tend to pass on their advantageous alleles to their offsprings. Now, that's the crux that we need to understand. So when we are saying that these advantageous alleles are being passed on, what it implies is that over a period of time, we expect change in alleles. So if that is the case, then we can say that there is a change in allele frequency. Okay? That is basically what is obvious from what we have studied so far. Okay? So let's try and understand what is Hardy-Weinberg principle now. Hardy-Weinberg principle is basically, if I were to give you an example, let's talk about any particular phenotype that is being controlled by the following two genes. This is, of course, we know dominant. And of course, this is something that we know that is recessive. कोई भी suppose कर सकते हैं, I'm not necessarily taking a name. Now, if we are considering these two alleles, what will be the possible genotypes for this particular alleles? We will have three possible genotypes. We will have homozygous dominant, we will have heterozygous, and we will have homozygous recessive. Okay? Acha, you need to understand that we can calculate the number of these genotypes in a very large randomly mating population. What do I mean? So can I say that the frequency of genotype is the proportion to its total population? अगर आपको मेरी बात समझ में नहीं आ रही कि मैं क्या कह रहा हूं, तो let me give you a very simple example. Okay, now I mean, if the total frequency, if I'm talking in terms of frequency and in terms of percentage, the total can be considered as 1, और इस 1 का proportion होगा जो कि इन तीनों में divided होगा. And that can be according to any letter that I can suppose in terms of genotypes and in terms of alleles. So the frequency of a genotype is a proportion of the total population. The total is the whole population, and that is the 1. That's the total basically. Okay, and the frequencies are given as decimals. तो अब जो convention है, अगर अभी तक आपको मेरी बात पे confusion लग रही है, don't worry. Let me finish first, okay? So we use letter P. That's a convention. We use small p to represent frequency of dominant allele. Frequency of dominant allele. Okay, that's a convention. That's what the Hardy-Weinberg principle is. And we use letter Q, small q, to represent frequency of recessive allele. Frequency of रिसेसिव एलील। ठीक हो गया जी। तो अगर if if I were to say that the total for a population is 1, then can we try and make an equation relationship between the following? ओके मैं आपको हार्डी वेगवर्ग प्रिंसिपल अभी तक देखें, मैंने आपको स्टेट नहीं किया कि उसकी थ्योरी की स्टेटमेंट क्या, आई विल कम टू दैट, but let's just try and see what this means. This will mean that if I add the frequency of dominant allele and recessive allele, they should equal to 1. And that is the first equation, equation 1 of Hardy-Weinberg principle. There are total 2 equations. ठीक है, इनकी अगेन अगर ये मैंने आपको डेरिवेशन करके बताई है, अगर आपको समझ में नहीं आई अभी तक मैंने क्या कहा है, जस्ट रिमेंबर दिस. P represents frequency of dominant allele, Q represents frequency of recessive allele, and when you add both of them they should be equal to 1, and that's what the first equation of Hardy-Weinberg principle represents. Okay, अच्छा अब अगर थोड़ी सी मैं आपको मैथ्स समझाऊं, तो अगर इक्वेशन की एक साइड को हम स्क्वायर करें तो दूसरी साइड को भी क्या करना चाहिए, स्क्वायर करना चाहिए. सो इफ आई से दैट यू हैव टू स्क्वायर दिस एंटायर इक्वेशन, व्हाट विल इट ओपन टू बी? ये ओ लेवल्स की मैथ्स है, अगर आपको याद हो, a प्लस बी होल स्क्वायर क्या होता है, a स्क्वायर प्लस 2ab प्लस b स्क्वायर, समथिंग ऑन दिस इफेक्ट. Am I what I'm saying, is it true? मैथ हेटर्स और मैथ लवर्स, मैथ्स किस किसने रखी हुई है लेवल्स में? किसी ने भी नहीं रखी हुई मेरे ख्याल से. चलें बहरहाल, I don't know if you remember this or not, but if I square this, this should be equal to p square plus 2pq plus q squared. ठीक है जी, that equals to 1. 1 का स्क्वायर करें तो 1 ही रहता है, अगर हम एक साइड पर स्क्वायर करें तो ऑटोमेटिकली हमें दूसरी साइड पे भी स्क्वायर करना चाहिए. तो अगर लेफ्ट साइड के स्क्वायर को मैं ओपन करूं, दिस इज व्हाट द सेकंड इक्वेशन शुड लुक लाइक. ओके, so that is equation number 2 of Hardy-Weinberg principle. Okay, what does a p square mean? P square का क्या मतलब है? It's the chance of offspring inheriting a dominant allele from both parents. ठीक है, क्योंकि आपको पता है कि जो इनहेरिटेंस है, जो जीन्स हैं, वो दोनों पेरेंट्स से आ रही. That's what P square means. P square means chance of inheriting dominant allele from mother and father. और फिर, so let me write that down here for you. Chance of inheriting a dominant allele from both parents. A dominant allele from both parents. ठीक है, that is P squared. And then Q squared is again a chance of inheriting recessive allele. Chance of, क्योंकि Q आपको ऊपर मैंने बताया is representing recessive allele, so Q squared is chance of inheriting a recessive allele from both parents. ठीक है जी. And what does 2PQ mean? 2PQ is a chance of offspring inheriting a dominant allele from the father and a recessive allele from the mother. That is why ये PQ कितनी दफा है? 2 दफा है. So one dominant allele from father and one recessive allele from mother, and at the same time another chance is one dominant allele from mother and one dominant allele from father. Okay, again these are derivations and implications which you don't need to go into details of. आपके एग्जाम में, let me show you what I'm going to come to this question, but मैं आपको सिर्फ दिखाना चाह रहा हूँ कि देखें एग्जाम के अंदर उसने ये इक्वेशन वगैरह दी होती है. It's just that we have to do the working, so you don't have to worry about what the derivation is. Like, since we're doing that topic, so I have to explain it. But there is something important that we need to understand. Now let me tell you what this principle is all about. So if I were to put this in words, I will write that the Hardy-Weinberg principle states that in a diploid sexually reproducing organism reproducing organism, allele and genotype frequencies, allele and genotype frequencies uh, remain constant from generation to generation, from generation to generation, as long as certain conditions are met. As long as certain conditions. यानी कि एक second. So let me read what I've written again. Hardy-Weinberg principle states that in a diploid sexually reproducing organism, the allele and the genotype frequencies. अब जरा यहाँ पे रुक जाएं. There are two things that this Weinberg principle is talking about. And those two things are allele frequency or genotype frequency. Okay, this is very important. The first equation represents the allele frequency, and the second equation is dealing with the genotype frequency. That is basically something that we need to understand, because taking a small p is representing frequency of dominant allele, or small q is representing the frequency of recessive allele. So that is dealing at allelic level. लेकिन जो second equation है, that is dealing with genotype frequencies. Anyhow, अभी मैं कैलकुलेशन पे नहीं आ रहा. So what this principle is stating कि ये allele frequencies change नहीं होती. Wait, abhi when I started this topic, I set the context with this idea that in natural selection and evolution, the allele frequencies are supposed to change because that's what natural selection is. So then what is this Hardy-Weinberg principle all about? Well, वो ये कह रहा है that they remain constant if certain conditions are met. और वो conditions क्या हैं वो important है exam perspective से. Number one, population large हो. Population is large, ठीक है? Which means that there is no genetic drift. And we talked about yesterday what genetic drift was. That's a spontaneous change or mutation in the genes. Number two, mating जो है वो random हो. Matings are random. Number three, no mutations, no net mutations. That's a good word. No net mutations. यानी कि overall free alleles पे कोई change नहीं आ रहा. Okay. Or there is no migration. Organisms एक ही जगह पे हैं. And there is no selection pressure. No selection pressure. If all of these conditions are met, only then we will have the allele and genotype frequencies to remain constant. अब मेरा आप सबसे एक क्वेश्चन है, मुझे आप ये बताएं, do you think that this will happen in real life? That there are no net mutations, matings are totally random, or migration nahi ho rahi, no migration, sorry, no migration. I mean, that is not possible. Then why, abhi tak, then why on earth do we have this formula in the first place? I mean, why do we have to use these calculations? Well, the answer is when the ratios of different genotypes in a population have been determined, the predicted ratios in the next generation can be compared. क्या मतलब? देखें, we can use Hardy-Weinberg theorem. We know that we can calculate these allele frequencies, और हम t-test को use कर सकते हैं to see if there is a significant difference between the existing allele frequencies and जो हमने इससे calculate की है. ठीक है? I know this idea, unless we jump into the paper and we see how this thing works, can be slightly challenging. But the idea is very simple. It's basically a theory and an assumption कि अगर ये ideal situation हो, तो allele frequency change नहीं होती. But we know that this ideal scenario is never met. Of course, that's never met. So therefore, we have differences in allele frequencies. तो हम आइडियल एलील फ्रीक्वेंसी को कैलकुलेट करते हैं और ओरिजिनल को देखते हैं, और फिर इनका जो डिफरेंस है उसको हम वी carry a test which is known as t test, and we say, okay, is this difference really significant, और या फिर it is by chance significant में ये सारे factors हो सकते हैं कि या तो कोई mutation हो गई होगी, या फिर there is some migration, या there is some selection pressure, and so on and so forth. Please tell me that you are not confused. Who is confused? Let's be very honest. Should I pick and choose? चलिए ज़ैनब आपसे शुरू करते हैं. I don't know if your mic is working. You said in the chat. ज़ैनब क्या ख्याल है? कुछ समझ में आता है? I don't know if you saw natural selection की वीडियो या नहीं, but this is actually quite related to the previous lesson. Rabia, does this make sense?
Sir, I'm slightly confused क्योंकि मुझे पता नहीं कि questions कैसे होंगे.
चलिए उसके लिए असल में ना मैं टाइम आज थोड़ा है. आई डोंट वांट टू जंप. अच्छा, सो इफ यू आर कंफ्यूज्ड then I want you to trust me till tomorrow, and when we will do the questions inshallah I will come back to this and this will make super sense. Abhi generally as an if you only understand 50% of what I have said inshallah then असल में ना हम derivations में नहीं जा रहे. वो FSC में derivation है इसकी बहुत ज़्यादा, but that is never going to be asked. मैंने आपको question की शक्ल दिखा दी है. अभी मैं क्वेश्चन के अंदर नहीं जा रहा कि क्वेश्चन में उसने ये सारा कुछ दे दिया होता है. इट्स जस्ट अ सिनेरियो एंड वी हैव टू डू द वर्किंग. सो इंशाल्लाह ये एक ही क्वेश्चन मैंने आज रखा है, लेकिन इसका आई थिंक हम थोड़े ज्यादा क्वेश्चंस में जाएंगे. सो नाउ व्हाट वी आर लेफ्ट विद इन दिस टॉपिक आर टू थिंग्स. एक्चुअली वन थिंग, दैट इज आर्टिफिशियल सिलेक्शन. कल पहले हम इसके पास पेपर्स प्रैक्टिस करेंगे, and then we will jump on to artificial selection and do questions for artificial selection, जिसके सबसे ज़्यादा questions हैं इस topic में past papers में, and then inshallah we should be finished. So if you're still confused with today's topic, please make sure that you don't miss the past paper practice for Hardy Weinberg questions tomorrow. You do often find them in the exam. ठीक है जी. मैं ज़रा syllabus पे जाना चाह रहा हूँ और आपको एक bird's eye view दिखा दूँ कि we are actually done with this topic. Okay. All right. Okay, so let's begin from the first point. 17.A, variation, differences between continuous and discontinuous. And this is what we did in the first lesson. Explained with examples how environment may affect the phenotypes. This is basically part of continuous variation, because you know continuous variation, it's not only the genes, but it's also the environment. Okay. ये टी टेस्ट की हमने आज बात की है. यूज टी टेस्ट टू कंपेयर द वेरिएशन ऑफ टू डिफरेंट पॉपुलेशंस. ओके, और अगर उनमें कोई वेरिएशन है तो उसके डिफरेंस को हम देखेंगे, इज इट सिग्निफिकेंट और नॉट, एंड द पैरामीटर्स आर द सेम, द वंस दैट वी डिड फॉर chi स्क्वायर्ड. क्रिटिकल वैल्यू के साथ कंपेयर करेंगे. अगर उससे कम होगी या उससे ज्यादा होगी, वी विल डिसाइड इफ इट्स सिग्निफिकेंट और नॉट. Again, we will look at the question inshallah tomorrow. D part, explain why genetic variation is important in selection. Again, we talked about this when we were doing natural selection. Okay. Natural selection may explain the natural selection occurs as populations have the, again, उसने थोड़ा सा explain किया, struggle for existence and all of that. That's basically natural selection. And then all of the types of natural selection: stabilizing, disruptive, and directional selection. And then explain how how the selection, the founder's effect, and the genetic drift may affect allele frequencies in the population. Again, this idea is very important, allele frequencies. हम जब natural selection की बात कर रहे हैं, at the end of the day, what we're talking about is change in the allele frequency. So we talked about this genetic drift and the founder's effect also. And then this is what we talked about today: use Hardy-Weinberg principle to calculate allele, genotype, and phenotype frequencies in a population, and explain situations when this principle does not apply. All of the points that we saw. Again, I want you to trust me for this topic till tomorrow, inshallah, when we do the past papers. Describe how selective breeding, ये हमारा रह गया, ये हम कल करेंगे. और इसी की examples हैं. इनमें से कुछ आप कर भी चुके हैं O levels में, वो high production of milk cow wali, but again, these are three examples that we have. All of this is for tomorrow, inshallah. And then finally, the theory of evolution and natural selection, molecular evidence, okay, with reference to mitochondrial DNA and protein sequence DNA. These are the two molecular evidences that we are supposed to see. Explain how speciation may occur, allopatric speciation and sympatric. आप देख रहे हैं इस टॉपिक के ऑर्डर को मैंने थोड़ा जंबल मंबल किया है, लेकिन वो मैंने इसलिए किया था बिकॉज आई बिलीव कि उस प्रोग्रेशन में चल के थोड़ा कॉन्सेप्ट इजी हो जाता है, अदरवाइज थिंग्स गेट मिक्स्ड अप. एंड देन अगेन pre-zygotic and post-zygotic isolating mechanisms. And then finally, explain why organisms become extinct with reference to climate change, competition, habitat loss, and killing by humans. ये चार चीजें हैं. I really want you to go through your textbook and make sure that if you get a question, your answer revolves around the following four things. I personally have never come across a question. I need to recheck also, लेकिन बार मैंने काफी देखा था दोबारा से. I couldn't find any question with regards to extinction, but it is related to conservation, जो कि ये 18th topic में 3 में है, वो हम तब भी इंशाल्लाह दोबारा बात करेंगे. ठीक है जी. So I hope that clarifies. किसको ये टॉपिक बोरिंग लगा? मुझे तो बहुत बोरिंग लगता है. I don't know about you guys, but I mean, but again, that being said, it's part of your syllabus, so even if you think it's boring, we have to live with it. All right. Any questions? No questions? Okay. Um, चलें जी, इंशाल्लाह कल आपसे मुलाकात होती है same time. I apologize for being slightly late today. See you tomorrow. Please make sure that you don't miss tomorrow's lesson. And मेरी आपसे रिक्वेस्ट है, ideally speaking, थोड़ा सा टाइम निकालें मेरी खातिर आधा घंटा और इस टेक्स्ट बुक के इस टॉपिक की जरा पूरी रीडिंग कर लें तो क्या ही बात होगी. I don't reiterate this point again and again for no other topic, but I'm doing it for this topic. And there's a reason why I'm doing this. So I hope you understand. Thank you. Jazakumullah khairan. Inshallah, see you tomorrow, 7. Assalamu alaikum.